This is the 12 volt DC adapter. You see the burning, and there is a liquid inside it. So definitely there is a liquid damage. You see that? On these MOSFETs, I think. Yeah, must be a MOSFET. And look like there is some resistor. Yeah, this resistor, I can't tell what's the value of this resistor. This 10 kilo ohm. This one here, we don't know. Yeah, it's like a simple power supply. So we have the source of the power, 110. We have rectifier bridge, fuse, and we have the B capacitor. Yeah, the transformer, it has two coils in the primary side, this one, and there is another coil, this one and this one. I think this one is for the VCC. Let's go to this capacitor and this diode for this switching IC. And we have voltage start. It came from these two dividing resistors. This is 150 kilo ohm. Then this diode, or let's see if that's shorted. The MOSFET, I don't think the MOSFET is short, because if it does, should be the fuse goes, like the fuse should be goes bad. Let's see. So the fuse is still good. It means the MOSFET basically should be still good. Or no, let's see. No, the MOSFET is not good. So I think maybe beside blowing the fuse, it's blow this resistor here. So we have this MOSFET is shorted. We have one resistor over there is burned. We don't know about the IC if it's still good or not, and that diode we don't know if it's good or not. So let's check that. So this resistor is completely open. You can see it's burned, and this diode but because it's connected to this resistor, we can't measure that diode. Yeah, we are going to need to move the diode or disconnect one side. So let's move it here and we measure it. You can see the diode is connected to this resistor. Both sides of the diode connected here. This is 10 ohm, so 0.5. And if we flip, is open, so the diode is good. This diode here, 0.07, that's low. And if we flip, 0.07, both sides is okay. That's a VCC diode. What about this one? 0.4 and open. Yeah, we need to take that diode and measure it. This one here. But that's very low. like that, the side, and we measure it. So it's open. So the diode is good. Or this resistor here, that's the problem. And we are going to do the same way as we measure these resistors when it's burned. Like this resistor, there is a wire inside it. When it's burned, it means that wire is cut. So how we measure the resistor if we can see the colors? This is what we do. Look where is the cut. It means we scratch the resistor a little bit. If the cut right here, so we keep measuring till we reach the cut, and it's going to give us an open line. So the closest point to the cut, example, if it is 120 ohm from here to the closest point to the cut, 120 ohm, then we measure the other side from this point to the closest point to the cut. Maybe it's going to be like, example, is going to be 200 ohm. Then we add 120 plus 200, it will be 320. So the same way we are going to do to this one. So we are going to measure. You see the burns are right here, but we still have a little space. Yeah, that little space right here. Okay, let's go to the resistor mode. I just wanna, this is like maybe 10% of the resistor. So we have 100 ohm over here. From here all the way to here, 100 ohm. And from here, we have 0 ohm. Yeah. So I guess maybe like a 1 kilo ohm. We have 1 kilo ohm resistor or less. And I did check online for a similar schematic for this IC. As you can see, that resistor is connected to the pin number 6. That's the sense. So the sense pin, and I look for a similar schematic using this chip, and I found they use like 450 ohm resistor. So I'm going to use like 470 or 500 ohm resistor here, and we see. Or this one, that's 475 ohm. Yep, because it's connected on the parallel, it should be like half the value over there. So let's take one of this. Yeah, this pen is completely, that pad is burned and gone. Let's see if there is any short anymore. So no short. No short here. Check that diode. So could be the IC shorted maybe. Yeah, the VCC is very low to the ground. Yeah, maybe the IC is shorted. Let's measure this resistor again. Yeah, now is alright. Yeah, we already removed the MOSFET and we're going to check if the IC making any wave. So we plug it and must be the pin number 8 is the gate. And this one is gonna go to the ground side in this source resistor. Yeah, the IC doesn't make any signal. No. No, that's not true. So voltage start is 11 volt. So we have the voltage start, but we don't have any. So definitely the oscillator is bad. Yeah, I don't have any IC that's matching this one, but we can use this one. This is our oscillator and switching IC module. It means this is going to replace all this here. It's going to replace the MOSFET and the oscillator. Alright, let's check if the optocoupler is connected to the ground, because we need it to be connected to the ground. No, it's not. Yeah, it does. Yeah, the optocoupler is connected to the ground. So the green is going to go to the positive side of the capacitor. So that's the positive side of the capacitor. It's go to this. Yeah, we can connect it to. Now the white is go to the optocoupler. So that side of the optocoupler is ground. This is the reading side of the optocoupler. We can solder it here. Red is go to the VCC, the positive side of this capacitor, or the positive side of this, yeah, the positive side of the diode of this capacitor. That's the VCC. The black is go to the ground, the hot side of the ground. That's the negative side of the capacitor. Yep, that's the ground. And the yellow one for the drain. The drain is this one here. Let's go to the transformer. So let's check again. Yellow for the drain, that's connected to the transformer. This one, from where it was the MOSFET, the drain of the MOSFET. The black is the ground, connected to the negative side of the capacitor. Red is the VCC, the positive side of the diode and the VCC capacitor. White is the feedback. The green, it's go to the positive side of the capacitor. That's the positive side of the capacitor. Yeah, to check the VCC, we can look at the second coil and the hot side. So that's one. Let's go to this. Let's go to the capacitor. Yeah, we can see this diode is connected with that resistor to the transformer. Okay, time to check it. Abracadabra. Alright, we have the green light. That's good. You see the green light? Okay, let's check the voltage. $23 So we have 23 volt. I think it's supposed to be 12 volt. Here it's at 24 volt, but yeah, the IC is cold. It's not hot at all. It's 19. I don't get it, because this one is getting the signal from the optocoupler and we didn't do no modification in the output, the optocoupler. So but why we have 24? And right here it said 24 volt. It said 12 volt. Right here it said 12 volt. Doesn't say 24. This one here. Yeah, I'm not sure why it's giving me 24 volt, but I think the safest way is just to put it on a 12 volt transformer. I'm just going to use a 12 volt transformer. I'm not going to use 24. So this is just a regular transformer, and we are going to use the wires. Alright, let's plug the device and see if it's gonna work. Alright, the output, yeah, looks good. Yeah, it works. It works. Yep, we have the screen, it's warming up. Have the lights. So that's the power supply we replaced. And let's plug it. The screen is on, and that's what's the problem was. Like, the screen doesn't power on. The customer here, the pump, but it won't turn it on. So which was the 12 volt power supply. I still can't understand why the power supply, after we fix it, it's give us 24 volt, and here it said 24 volt, and that's the original power supply. Yeah, still I don't get it. But anyway, the device is fixed and ready to go. You can see the fog. Alright, that's all for this video, and see you again.